Hey y'all, this is Mrs. Tran-Bloom. I'm gonna pick up where we left off last time. Okay, so this is example 6. Find its inverse, graph f and its inverse on the same coordinate plane. Okay, so here's the coordinate plane that we're using for graphing. So we can do this multiple ways. So we can find its inverse first and graph both of them. Okay, so here we go. First, check this out. Is this a one-to-one? So this is a question that you always want to ask yourself. Is the function I wrote function with an E in the end. Function 1 to 1. Okay. Because if it's not 1 to 1, we have to restrict its domain, so it can be 1 to 1. Because if it's not 1 to 1, we can't find its inverse. Okay. This is a line, so all lines are 1 to 1 unless it's a horizontal line. So since this is not a horizontal line, it's definitely a 1 to 1. So to find its inverse, we're now going to switch x and y. Okay, then solve for y. So this piece is really important. You have to solve for y. You can't just switch it and then leave it alone. Okay, so this is y equals 2x plus 3. So now we're going to write x equals 2y plus 3. We're going to solve for x, so we're going to subtract, we're going to solve for y, so we're going to subtract 3 from both sides. So this is x minus 3 equals 2y. We are now going to divide each and every term by 2, or we are going to multiply each and every term by a half. Okay? So dividing and multiplying, they're exactly the same thing if you're going to multiply by the inverse, or reciprocal. So 2 times 1/2 is currently 1, so or 1y. Then I'm going to distribute the half, so 1/2 times x is 1/2 x. 1/2 times -3 is -3 over 2. Oops. Well, my y didn't quite line up. Equals y. Just kind of bring it down so that way it kind of lines up nicely. So to write its inverse, I would like for you to use the inverse notation. F inverse of x equals to 1/2 x minus 3 over 2. Box it up. Okay. Alright, because we didn't restrict anything on the original function, there's no restriction for the inverse. So now we just have to graph out your two functions together. So the first function, your f of x function, is 2x plus 3. Okay, I'm going to use the y-intercept is at 3. So the y-intercept is when x is 0. Alright, now it doesn't matter what function is thrown at you. To find a y-intercept, you just have to set x equals to 0. And to find an x-intercept, you set y equals to 0. So it's that simple. Okay. So when I put in 0 for x, 2 times 0 is 0. So I'm just going to cover that up. 0, comma 3 is my y-intercept. 1, 2, 3. 0, comma 3. Label that. Then I'm going to use the slope-intercept form. So that's the intercept. I'm going to use the slope. The slope is 2, or 2 over 1. So that means rise 2, right 1, up 2, right 1. So do that for all, fill up the entire coordinate plane until you can't fill it up anymore. And even when you have gone all the way to the top, I want you to go all the way to the bottom. So down 2, left 1, 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 down 2, left 1. Okay. Now I don't want you to use a freestyle. So what you would like to do is take out your ID right now, or a ruler, or a business card. That's my case right now. And connect all of your dots. Okay. We're going to label this f of x. Because you're going to have multiple functions or graphs on one coordinate plane, always label. Alright. Now with that said, we're going to go and graph your inverse, which is we found on the bottom. For this, you can do two things. You can use the points that you currently have. Okay, so let's just say I want to use this point right here. That's -2, comma -1. So -2, comma -1. You can use those 2 points with your x and y and graph it. Or just to kind of teach you how to graph it a different way, I'm going to teach you how to graph it using the x and y intercept. Okay? Alright. And again, x-intercept, y is going to be 0. Okay, so here we go. When y is 0, we got 0 equals 1/2 x minus 3 over 2. Then I'm going to add 3 over 2 to each side. So now this is 3 over 2 over here equals 1/2 x. To get rid of 3 over 2, I'm going to multiply by its reciprocal, which is 2. Okay. Now you can also put 2 over 1. 1/2 times 2, that will give me an x value. Then 2 times 3 over 2, you can cancel those out. So now you end up with when x equals 3. So when y is 0, x is 3. So 3 comma 0. Okay. So we're going to go in and plot 3 comma 0. Which technically, if you were to switch that point right there, that's what you have. So 3 comma 0. Then if I were to find the y-intercept, x is going to be 0. Okay, so if x is 0, I don't even have to do the math. X is 0, y is negative 3 over 2. So when x is 0, y is negative 3 over 2. So that's negative 1.5. Okay, so when x is 0, y is negative 3 over 2. So I have 2 dots. 2 dots is what you always need for a line. All right. So connect my 2 dots with a straight edge. Okay, label this f inverse of x. So check that out. Those are the two functions. One's a regular function, one's an inverse function. Now let's check it out that, hey, does it look like, okay, if I were to fold it along my identity line, which is this line that I'm kind of plotting out right here, so I can neatly see what it looks like. This is my identity line, okay. Y equals x is my identity line. When I fold my coordinate plane along the identity line, is it symmetrical? Okay, so is the top going to line up perfectly to the bottom? Is the top lining up perfectly to the bottom? If you said yes, that means you have graphed it correctly. If you said no, then obviously you need to go back and fix it. Alright? Excuse me. So now let's move on to the next example. Alright, so example B. Okay, directions is exactly the same. So example B says f of x equals x squared plus 4. Now let's check this out. There is a restriction on the domain of f of x. It only wants you to graph it on the positive side. So let's just say that this is on your test and you don't know what it looks like. If you don't know what it looks like, then make a table. Okay, here's f, here's x, and here's f of x. When x is, because it wants the domain to be greater than 0 or equal to 0, I'm going to pick 0 to start with. 0 squared is 0 plus 4 is 4. 0, on the next one it's going to be 1. 1 squared is 1 plus 4 is 5. I'm going to pick 2. 2 squared is 4 plus 4 is 8. Okay, so usually a line it's minimum 2 points. Anything else you might want to use at least 3. So now if I have 3, I'm going to plot that. When x is 0, y is 4. 1, 2, 3, 4. Many of you already know that this is a parabola that is translated 4 units up. Okay, so that's why we have, instead of starting 0, 0 on vertex, we go in 0, 4. 1, comma 5, 2, comma 8. This is a 10 by 10, so I know 8 is just 2 units below. So this is my f of x function. Notice how it only wants x. It's on the positive side, so there's no negative side. And the reason for that is, let me just get a pencil and sketch it out for you. The reason for that is if I put the negative side back in here, what's happening to this function? Okay, it would not be a one-to-one. So that's why you have to restrict it. So in a problem where it's not restricted, you have to restrict it to make it a one-to-one. Okay, so I just have to erase that piece. Alright, so now to find its inverse, you can do it a couple ways. Because you have to graph it out. Okay, so to graph it out, I can just go ahead and switch my points. So here's my x, and here's my f inverse point. Okay, so I'm going to switch x and y. So this is now my x. My y is now 0. This is now my x at 5. My y is now 1. My x at 8. My y is 2. So even before finding the inverse function, I can just graph it out. So when x is 4, 1, 2, 3, 4, y is 0. When x is 5, y is 1. When x is 8, y is 2. So I don't need to find the inverse function to graph out its inverse. Okay. Now, and again, as you know, you need to double check to see if this is, so later we're going to double check to see if we're right. Okay. So plot in your identity line. So the identity line is y equals x. So that means when x is 5, y is 5. When x is 1, y is 1. When x is negative 1, y is negative 1. And so on and so forth. Okay, that's why it's called the identity line, because x is identical to y. Alright. So look at my identity line. Is the top exactly lining up with the bottom, or is the top symmetrical to the bottom? If you said yes, then you have graphed it correctly. So now my difficult task is to find the inverse function. So we're going to switch x and y. So this is y equals x squared plus 4. We're going to go x equals y squared plus 4. This has a restriction of x is greater than or equal to 0. We now have a restriction of y is greater than or equal to 0. This is pretty much your range. Okay, we're going to solve for y, so we're going to minus 4. So we're going to have x minus 4 equals y squared. We're going to take the square root to both sides. Okay. Anytime you take a square root, you're going to have two answers, so plus or minus square root, x minus 4. Now the problem is this. Earlier, we said, hey, y has to be greater than or equal to 0. So right now, this is a negative y and that's a positive y. So when you find your inverse function, you can only pick one. Okay, f of x is greater than 0, so we're going to pick the positive one. So we're just going to have a positive x minus 4. So this is my inverse function. Now, in addition to knowing what the range is, so your range is already known. Okay, y is greater than or equal to 0 because of what we restricted earlier. You also have to find the domain. What is it the domain can't be under a radical? Under a radical, your domain can never, ever, ever be 0. Okay, so if I put 0 in, 0 minus 4 is 0. So right now I know my domain can't be 0. If I put 1 in, 1 minus 4 is negative 3. Can't have a negative under a radical. So the smallest number I can have is 4. 4 minus 4 is 0, and I can totally have a radical of 0. So the, excuse me, the smallest number I'm going to have is x is greater than or equal to 4. Okay, so this is your domain. You have to limit it to domain, and this is your range. And if you look at your graph, look at this. X is 4 and beyond, right? Y is 0 and beyond. So you know for sure, doing the algebraic and the graphical, they have to match up. Alright? Okay, so if this is too much and I'm going too fast, just pause it, finish writing, finish listening, and then go on to example 7. Okay. So example 7, it just said find its inverse. Excuse me, I have a sore throat, so. And the reason this one, I'm not asking you to graph it out, is because to graph out a rational function and its inverse is going to be really messy. So that's why I don't really need you to graph it out. So here we go. Find its inverse. We are now going to switch the x and the y. But before we do that, let's talk about why we have to exclude 1 from our domain. If I don't exclude 1, then 1 minus 1 is 0. So you can never have 0 in the denominator. If you have 0 in the denominator, you don't even have a function to begin with. So we have to exclude the domain that prevent it from being a one-to-one or being a function altogether. Okay, so x equals, this is 2x, so it becomes 2y plus 1 all over. This is x minus 1, so it becomes a y minus 1. This one says x can never ever be 1, so now we have to say y can never ever be 1 now that we've switched. Alright, this is going to end up being your horizontal asymptote later. Okay, so from here, we're going to make x into a fraction by putting 1 underneath, and we're going to cross multiply. Okay. So if I cross multiply, I have x times the quantity of y minus 1 equals 2, and then I'm going to cross multiply this side. That means 1 times 2y plus 1, which is itself. I'm going to distribute x times y is xy. X times negative 1 is negative x equals 2y plus 1. Your goal is to solve for y, and currently you got y in two different places. So what you might want to do is to move it to one side. Okay, I'm going to move it to this side. At the same time, I'm going to move the non-y to the opposite side, so plus x. So currently I have x times y minus 2 times y equal to 1 plus x, or x plus 1, depending on how you want to write that. Well, currently, again, we're solving for y. So to solve for y and having y in two different terms is not going to help us. So we're going to factor out the same greatest common factor, in this case, which is y. So if I factor that out, I have x minus 2 equals 1 plus x, or x plus 1. From here, we're going to divide both sides by x minus 2. Okay, those will cancel. So now you have a y equals x plus 1, let's just write it in order, divided by x minus 2. So this is your function. So that is my inverse. So f of x equals x plus 1 over x minus 2. Box it up because that's my inverse. Okay, so now we have to talk about what we need to exclude. So as you can tell earlier, y cannot be 1. So this is actually your range. Okay, range y cannot be 1 because if I were to go for the horizontal asymptote, x divided by x, y equals 1. Because the horizontal is at 1, we can't have it in our, excuse me, I'm losing my voice. Oh, that sounds funny. So y equals 1. I'm sorry, I'm kind of sick. And then, so now, what is it that what is it that we need to exclude for a domain? We need to exclude values or value that will make the domain 0. So in this case, 2 would make it 0. So x can never ever be 2. So we need to exclude it, and that's what we have. Okay. Alright, so next piece. And again, please do pause it, okay, if I'm going too fast, and then catch up, and then go on to example B. Example B is asking for us to find the inverse as well. Okay, so let me just zoom in a little bit. So we have f of x equals x squared plus 2 all over 2 times x squared. And now, check this out. It's excluding. Okay, it only wants the positive side of this function. And the reason it does that is probably because this one is not a one-to-one. And just to kind of remind you what this looks like. Okay, let's quickly sketch this out up here. Okay, if I wanted to, I can find the horizontal asymptote, which is x squared divided by 2x squared. That's going to give me reduce x squared and x squared. That gives me a positive half. Okay, so that's my 1 unit. Positive half is going to be right here. This is my y equals 1/2, my horizontal asymptote. Then I'm going to look for the vertical asymptote, which is take the denominator, set it equals to 0. That gives me horizontal asymptote. I'm sorry, vertical asymptote, x equals to 0. Then I'm going to pick a right value of the vertical asymptote. That's the only critical point I have at this point. So I pick 1,000, positive 1,000 for x. Positive 1,000 squared is positive 1,000. Plus 2 is still positive. Positive 1,000 squared is positive, times 2 is still positive. So if you look at this, I have a curve on the right on the top. Then I'm going to pick negative 1,000. Square is positive. Negative 1,000, square that is still positive. So if you check this out, this is not a one-to-one. Okay, so because it doesn't pass the horizontal line test. And plus, I can have two different y values, two different x values, and still end up with the same y value. So from this, they just want, hey, you know what? To make it one-to-one, I'm just going to pick the positive side. And that's why this is limited from x is greater than 0, because I can't have 0 for the denominator anyway. So to find its inverse, we're going to switch x and y. So x equals y squared plus 2 all over 2 y squared. And then it says, hey, y has to be greater than 0. This is going to end up being arranged later. So from here on out, we're going to make this one into a fraction, and we're going to cross multiply. So when I cross multiply, I have x times 2y squared equals, when I cross multiply those, 1 times anything is itself, so y squared plus 2. X times 2y squared is 2xy squared equals y squared plus 2. Okay, So let me ask you a question. You're solving for y, and y is currently on both sides. What are you going to do? I hope you said move it to one side. Okay. If you said that, then you're correct. We are going to move it to one side. You can pick a side. It doesn't matter which side. I'm just going to go with the left. So we'll move it to the left. Now that it's on one side, what are you going to do? I hope you said factor out the greatest common factor. If you did say that, then you are correct. The greatest common factor is y squared. So we're going to take out y squared. That means you're left with 2x minus 1 equals 2. Then from here, we are solving for y, so we're going to divide this. So we have y squared equals 2 over 2x minus 1. And this is now y squared equals. I don't want to solve for y squared. I want to solve for y, so I'm going to take square root. So y equals plus or minus big radical 2 over 2x minus 1. Now, what's wrong with this? It has a positive y and a negative y. Okay. Earlier we said y can only be positive, so we can only take the positive piece. Okay. I'm out of space. I'm just going to move here. So my inverse function equals just the positive piece, 2 over 2x minus 1. Box it up. Let's talk about the domain and the range. We already know what the range has to be. The range has to be greater than 0. Now what is it the domain has to be? Well, first, the domain meaning that I'm going to take my VA. Okay, so what is the VA? Where is the VA at? So if I take my denominator, I set it equal to 0, x can never ever be a half. Okay, so in this case, and plus you're under the radical, so as you know, if you're under a radical, it can't be negative either. So if I put x is half in here, okay, so let's draw a number line really quickly. Here's 1 half. 1 half times 2 is 1. 1 minus 1 is 0. Because it's in the denominator, it can't have a 0. So currently I'm not including 1 half, and that's pretty much what my vertical asymptote is. I'm going to pick a value on the right, which is 1,000. 1,000 times 2 is going to be positive. Minus 1 is still positive. So technically I can have a positive number under the radical. And I pick negative 1,000. Negative 1,000 times 2 is negative. Minus 1 is still negative. I can't have a negative under the radical. So if you check this out, this is my domain. My domain's got to be greater than, x is greater than 1 half. Okay? Alright, and this is the end of my video notes. Please listen to it again. And you don't have to listen to the whole thing. Just listen it to whichever problem or example that you didn't understand the first time around. Okay? Alright, so let's talk about a joke. What do you think? Okay. Let's find a good joke. I have a toddler book of jokes here. So, here we go. What kind of sharks make good carpenters? So, what kind of sharks make good carpenters? Hammerheads. Okay, so hammerheads, huh? Because he's holding a hammer, or he's a hammerhead. Anyway, I need to find better jokes. But I love you guys all, and have a good day.